Trig, Saxon's Trig, Lesson 2, beginning on page 14. Section A is more on area, and as we discussed in Lesson 1, we know that the area of a rectangle or a square is found by doing length times width. So in the first example, where they list the length as 3 and the width as 2, they discuss what area actually does, and it tells you how many boxes or squares it takes to fill a shape. So if this one is 3, it's saying that there are 3 sections this direction, and this one is telling me 2, so 2 sections this direction. How many boxes does it take to fill the entire shape? Well, that is 6 boxes, and we find that by doing the length times the width, which is 3 times 2 gives us the 6. And as we also discussed in Lesson 1, how do we find the area for a triangle? And that is 1/2 base times height. And we talked about the fact that height, as you see on the top of page 15, can be given inside the triangle, the middle picture, or it can be the side, the very last picture, or it can be on the outside in an obtuse. And they go through a lot of explanation as to why this works, but at this point you basically just know that the area of a triangle is 1/2 base times height, and if you are interested in the whys behind it, you can study page 15. Part B in this lesson is cylinders and prisms. So what makes something a cylinder? Well, if its base shape is circle or oval and we turn it into a 3D, then it is a cylinder. It's not quite even there. My top is a little bit smaller than my bottom. But the idea is that it is circular top and bottom and connecting. It can be slanted the way I drew this one, which we would call oblique. I believe it's Q-U-E. So oblique, or it can be right if the top and the bottom are directly on top of each other identically, and this is straight, forming a 90 degrees at the bottom connection, then that would be a right cylinder. All right, so it does use a highlighted term here. There are several that I've sort of skipped over. So in the beginning of section B, cylindrical surface, obviously that is something that is either a circle or an ellipse, which is kind of the squished one. And if it does not connect all the way, they call it open. If it does connect all the way, they call it closed. And then the directrix is what they call the path that is making the ellipse. Not a term that they use a lot, but they do just make note of it here in this lesson. All right, the moving line, so the directrix could also be called element. Again, not a term that they use other than here in this lesson. Okay, looking for the next one. Parallel planes. These on a right cylinder would be parallel in their surface, flat surface as we talked about for a plane, and so in this case those would be circles, but parallel planes are going to be connecting if it's right. There they talked about that one, also called a right solid. Circular cylinder is if the top and the bottom are actually circles, and then anything else is just going to be called a cylinder if it is actually coming from an ellipse. They do use the term here elliptical cylinder. Again, that gets dropped usually and it's not continued to be called that. So circular cylinder, elliptical cylinder, right circular cylinder is getting more specific. There is the center of, which is going to obviously be the center of the circles. That's going to be the center for the cylinder. On the base, the line that connects the centers is called the axis of the cylinder, or typically ends up being called the height, but it actually doubles as the axis. And then oblique cylinders, as I've said, are ones that are slanted. Right ones are ones that stand upright. Okay, then near the bottom of page 16, what happens when it is not circular, but it has some other shape for its bottom? It goes from being a cylinder to being a prism. So at the bottom of page 16, it again shows you right oval cylinder, right circular cylinder, and then it changes gears to having a triangular base. Now this is not how they drew it, but basically, there you go. So basically, if you have a triangle that is the same top and bottom and those are parallel, that should have been a little bit shorter. It's not quite drawn to scale there correctly. But if the triangles are identical and they are right triangles, then it is what they have there in the middle picture, a right triangular. Now, they're using the word cylinder, but they're implying that it's a prism because it is no longer in circle. So rather than causing confusion, although it is technically under the heading of a cylinder, we're going to call them prisms more consistently. So I would call that one a right triangular prism. If it is a square, and that's connecting down. Oh, it's much harder for me to draw it that direction. I think I may have just gotten, oh no, those two sides would be set. Well, that's a little curve there in the back. So this one is going to be a rectangular prism if my base shapes are rectangles. And if they're squares, I can say it's a square prism. If all sides are identical, then it's going to be a cube. This one I do better this way. And so that's a cube. All sides are exactly the same. And then the very last picture they have there on the bottom of page 16 is a right cylinder. It goes back to the term cylinder and not prism because it has curves as part of its sides. Page 17 contains, as we said in lesson 1, any information found in the box is going to be super important. So for this one, it is the volume for cylinders and prisms. Now, if we talked here about the area being how much it takes to fill the bottom of a shape, volume is going to be what it takes to cover the bottom, and then however many identical layers you have of that coming upward, that becomes your volume. So volume is the 3D kind of a shape. So the volume is area of the base times the height. That's the overall basic formula for volume. So whatever the base shape is, find its area and then multiply it times the height, which represents how many levels of identical things you have making it form the 3D coming up. So what did they say in words? The volume of a cylinder or a prism is equal to the product of the area of the base and the perpendicular distance between the bases. A much more wordy way to basically say area of the base times the height. Now, they do show you the shortcut formula there just underneath those pictures, and then it gets to the next. Lateral surface area of right cylinders and right prisms. So let's pause for a moment and talk about what does lateral actually mean. So in a 3D shape, the lateral is not the identical top and bottom, whether it's drawn on a side, but the identical things are the base and the top. The other parts, the side parts, are what we call the lateral surface area. So if we need to find the area of the lateral pieces only, so lateral surface area, you're going to find the perimeter of the shape and multiply it times the height of the overall. So instead of finding the area of this rectangle here on the side and the one in the back and the one in the bottom, the shortcut is to find the perimeter of the base by adding all three of those sides and multiplying it times the height. The height, as you can tell, is identical in all three of those spots. So lateral surface area is basically do the perimeter times the height. So there longer wording is the lateral surface area of a right cylinder or right prism is the perimeter of the base multiplied by the height, where the height is defined to be perpendicular distance between the bases. And again, they have to be wordy to be very precise, but you're getting the idea. Now we move into the first example in this lesson, 2.1 on the bottom of page 17. The base of a right circular cylinder 10 centimeters high is shown. Find the surface area of the right cylinder. Dimensions are in centimeters. Now, I'm not going to draw the 3D part, but I am going to draw the base as they're giving it to you here. And they've provided us with the fact that that's 5, this is 6, and the radius is a 3. So if we are looking for the surface area of this entire shape, we need to find the area of the base. And how many identical of those will we have? One on the bottom, one on the top. So base times 2 plus the lateral surface area will give me the full surface area for this shape. So let's begin by finding the area of this base. It's in two parts, a rectangle part and a half circle or a semicircle part. So how do we find the area for the rectangle? 6 times 5 is going to give us 30. And then how do we find the area of a circle? Remember, our formula is pi r squared, but we don't have a full circle. We have only half of a circle. And what was our radius? 3. 3 squared is 9. So basically now we have 9 pi over 2. And we're going to want to do that on our calculator to turn it into a decimal number so that we can add it with the 30 and now have the area of the base. You'll double that base and then we'll work on the lateral surface area. And just for numbers' sake here, when they did that addition, they got 44.14, and you'll want to practice that on your calculator. Centimeters squared, again, everything in area is whatever the unit is squared. And we're going to multiply that by 2, and they did not give you that number yet that I see. Okay, and again, now let's move on to the lateral. So we know that that is the perimeter of the base times the height. So what is the perimeter of this base? 5 plus 6 plus this side is also 5. I believe they labeled that on the original. I just didn't put it on here. Plus, and now I need the perimeter for the half a circle. So we remember that that is pi times diameter for the full entire distance around a circle, but we only want half of that. So instead of doing pi times diameter, let's do pi times radius, which will be 3. So we now have 16 plus 3 pi. Again, you're going to want to put that on your calculator to turn that into a decimal. And that comes out to be 25.425 centimeters. And wait a second. Yes. All right, that is the perimeter part times the height of the whole shape. In the paragraph is where they gave me that information where it said that the height was 10 centimeters. So we're going to multiply that, which is going to slide that decimal over if you're doing it manually or you're doing it on your calculator. It's going to give you 254.25. And because we did centimeters times centimeters, it's now centimeters squared. Area is always squared. So we're going to take our answer here, which we can do quickly, and you can check it on your calculator. So 88.28 centimeters squared needs to then be added with the 254.25 for the final answer of 342.53 centimeters squared. Now example 2 asks to find the surface area for this right prism. Surface area wants the entire area of all of it. So again, we need the base twice and we need the lateral surface area added to it. So what is, and this is a plus sign basically, It should all be identical, and all of them are labeled as 2's going all the way around it. So what I see here is a series of squares or rectangles if I split them up, and I would then have 5 identical pieces. And this one here is a 2 because it matches this 2. This is a 2 because it matches that side of 2. So I know that they're all the same. So I have basically 5 identical areas of 2 by 2. So that's going to give me a total of 20. What are my dimensions? Oh, it does not say. So we're just going to do this in numbers at the moment. And then because I'm working on surface area, that's the area of the base, I have it 2 times again for the top. So the top and bottom together makes 40. Now we need the laterals, so we need the perimeter. 2 plus 2 all the way around. How many sides are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. So 12 times 2 gives me a perimeter of 24. And we need to multiply that times the overall height of the shape. And when you look at the 3D picture, they're given, it was given this way, and it was a 6 when this was a 3D shape. So 24 times 6 is going to be 144, adding with the 40. So our final answer is 184. And again, because it didn't tell me any units, I can actually say units squared or square units. It really doesn't matter which way you write that, but if you're going to use the shortcut with the exponent of the 2, you need to actually put the word first. If you're going to write it out, then you can put it in the other order, square units. And before I move on to section C, I'm going to stop the video here and do that one in another section.